Okay, so today we are going to be looking at quadratic applications. For your essential question today, I want you to explain how the different parts of a parabola apply to real world situations. So just kind of give me an explanation of what each piece of the parabola means in terms of a real world situation. So I've included a PDF of the keywords that I want you guys to put at the very beginning of your notes. So before you even begin these notes, you should have already completed the quadratic keywords paper, either by printing it out and filling it in or by drawing it into your composition book. Okay, so our GP today is this first real world situation. A stick is thrown off the edge of a 190-foot tall building with an initial vertical velocity of 64 feet per second. The equation that models the stick's height is given by the function h of t equal to negative 16t squared plus 64t plus 190, where h of t is the stick's height in feet and h is the time in seconds since the stick was thrown. So we want to pull the function from this. That's the thing that we're going to need moving forward with the different questions that we're going to answer. So we're going to take that h of t equals negative 16t squared plus 64t plus 190 with us as we move forward in the examples today. So for GP number 1, we are being asked how long it will take for the stick to hit the ground. So the biggest thing that you need to be able to do with these application problems is make sure that it's clear what you're being asked to find. So for this case here, we're looking for how long, which is time. Now, if you think back to the poster, the scenario that we drew before break, remember that we had the x and the y-axis. So I'm going to just do a quick sketch over here. So here we have the y-axis. Here we have the x-axis. And then we have a parabola that makes this shape here. So remember that the x-axis is what represents our time. So in our equation, you'll notice that the t has replaced the x because our x value represents time. And y is our height at a given time, at any given time. So that is what the y-axis represents. So what we're looking for is the time when the stick will hit the ground. So the first thing you always want to do is just kind of make your sketch so that you can get an idea as to what you're looking for. So how long it's going to take for the stick to hit the ground, we know that the x-axis represents the ground, and this right here is where the stick will hit the ground. Now this is an x-intercept. So two things. One, you have to be able to identify what it is you're looking for. And then secondly, you have to remember how to find those given pieces from units before we were here. So to find the x-intercept, we have multiple options. Those are our solutions, right? So we can either factor, we can square root, or we can use the quadratic formula. So remember that the square root only works when there's no b value. We have a b value, that's not going to work. And factoring only works if your equation is actually factorable. If quadratic formula works for every single one. Now, you're not always necessarily going to get really nice numbers. So you can choose to start with the quadratic formula. If you prefer factoring, you can start with factoring. I'm going to use the quadratic formula here. So for the quadratic formula, I'm going to identify my a, b, and c values. Now make sure that when you identify these that you're including the negatives. Those are super important. So a is negative 16, b is 64, and c is 190. So plugging into the quadratic formula, we know it's x equals negative b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. Now I'm going to use t equals because we're looking for time, which is what the x-axis represents. So our time is going to be equal to what we find with the quadratic formula. So negative 64 plus or minus the square root. Make sure you're using parentheses. 64 squared minus 4 times negative 16 times 190 divided by 2 times -16. So we're going to go ahead and simplify this. (64 squared gives us 4,096. -4 times -16 is going to give us a positive 64 times 190 is going to give us 12,160. Now, something to keep in mind when you're looking for the x-intercepts, the stick is going to hit the ground. Therefore, our parabola is going to intersect the x-axis, which means we should not get imaginary solutions with these real-world application problems. Again, we should not get imaginary solutions when we're solving these real-world application problems. So from there, we can go ahead and simplify inside the radical. Now you're going to have to use a calculator here when we work this out. So this gives us 16,256. So we're going to separate this to find our two different times here. So first, if you do -64 plus the square root of 16,256 equals, divide that number by -32, you're going to get -1.98. If you do -64 minus the square root of 16,256 equals, divide that number by -32, and you're going to get a positive 5.98. Now remember, we have two x-intercepts here, but this is 0, which means that this represents negative time, which is not possible. So when we solve and we get our two x-intercepts and we get that negative value, we're going to throw that negative value out. You're still going to show that in your work, but we're going to throw that negative value out and go with the positive time value. So the stick is going to hit the ground after 5.98 seconds. Okay, again, how long? Make sure that you differentiate between height and time with the way the question is asked. So we're looking for how long, the amount of time that the stick is in the air, how long it takes to hit the ground. And that is that one. All right, for number 2, how high above the ground was the stick when it was thrown? So I'm going to go back to our picture. You already have it drawn in your notes. You don't have to redraw it multiple times, but with each question, you should have a picture just to kind of help represent that scenario. How high above the ground was the stick when it was thrown? So this is when the stick was thrown at this level here. Again, remember the y-axis represents the height. The x-axis represents your time. This value here is our y-intercept. That's our starting height or the initial height. And that number comes from our equation in standard form, which we have here. It is our constant, which is always the y-intercept of our function. So how high above the ground when the stick was the stick when it was thrown? Again, make sure that you're differentiating between height and time. That's going to be a height, which is a y value, the y-intercept, and that's going to be 190 feet. So the stick was 190 feet high when it was thrown. Okay, next one. When does the stick begin to descend? So that when is going to be time. When does the stick begin to descend? So we hit our max and then our graph begins to descend or decrease. So again, we're looking for time, which is the x value, right? Our x-axis represents time. So when does the stick begin to descend? So we need to find the time that the stick is at this height. The time the stick is at this height. So this is our vertex, but it's the x value of the vertex, which is the axis of symmetry. So recall, to find the x value of the vertex, which is also the axis of symmetry, we use the formula x equals negative b divided by 2 times a. That is how we find the axis of symmetry, which is also the x value of the vertex. Now our x is going to be replaced with t for time. Our a and b values are still the same. So t is equal to negative 64 divided by 2 times negative 16. That's negative 64 divided by negative 32, which gives us a positive 2. So when does the stick begin to descend? After 2 seconds. So let's just take a look at this, make sense of this. The stick is thrown from this height here. It increases until it gets to its maximum height. Then it turns around and it begins to decrease back to the ground. So this is the point where the stick begins to descend, and the time at which it begins to descend is the axis of symmetry. How high did the stick go? So once again, I want to go back to my picture, my sketch. How high did the stick go? That's our height. That's a y value. And that's going to be our maximum height. That is how high the stick went. So to find that value, we already found that the axis of symmetry is 2. Okay, it's at its maximum height at 2 seconds, but now we need to find the height at 2 seconds. So h of 2, because 2 is when it reaches its maximum height. So now we're looking for the height at 2 seconds is equal to negative 16, substituting 2 in for t. Go through and simplify this. 2 squared, remember order of operations, always do your exponents before you multiply. 2 squared gives us 4. 4 times 16 gives us negative 64 plus 128 plus 190. We go ahead and simplify. Negative 64 plus 128 is 64. 64 plus 190 gives us 254. So the height at 2 seconds is 254. But the question is, how high did the stick go? The stick went 254 feet. Went up 254 feet. So that is our application. Make sure that you have toolbox items. This should be a number 4 here. Make sure you have toolbox items for each of the 4 guided practice problems. Again, make sure you're differentiating between how the time and the height here. In your practice, make sure that you're drawing a sketch for each of your different questions.